So thinking back to how we originally defined these things, remember that the sine function is designed to tell us about a length opposite of an angle, at least in terms of a right triangle. Now, with oblique triangles, we don't have that nice right triangular idea built in, but we can bring it in if we talk about it in terms of an altitude or height. And also, when we're talking about the area of a triangle, we have 1/2 base times height. And we can use the sine function in terms of that height, thinking of it like a right triangle inside, to get the area in terms of sine and those angle measurements. That is, depending on how we draw our altitude, we can get the area as 1/2 BC sine of A, or 1/2 AB sine of C, or 1/2 AC sine of B, depending on what arrangement of information we have and know and need. So, for example, if we want to find the area of the given triangle with the measurements shown below, we have the two sides of length 8 and 12 with the angle C having measure 135 in the middle. In this case, we can treat A as being the length 12 and B as the length 8, as we're having those opposite of the angles, as it were, which means C, as it's given, is 135 degrees, and we'll use that second arrangement given what we have. That is, for this triangle, we have that the area is going to be 1/2 AB times sine of C, where here that has form 1/2 times 12 meters times 8 meters times sine of 135 degrees, which here ends up being approximately 34 meters squared, to be sure. And then you see the law of sines. You may have heard me say it a couple times, but even if you didn't, you probably think to yourself, well, there should be a law of cosines, right? And in fact, there is. And that's what we'll be seeing next in section 6.2, which gives us a way to handle other kinds of triangles.